Okay, today's lessons for LEAP, we're going to target lessons 15 and 16. I'm going to start with lesson 15 and we'll work through that, and then I will move on to lesson 16. All right, so for A, this is a demonstration, so I need you to really pay attention to the actual picture here because you're not going to physically have a piece of string and you're not going to be cutting it. So pay attention to the picture for A when I kind of go through it. So you see a string here, okay, and this little symbol here kind of represents a knot that's in the string, okay? And it's going to say, fold a piece of string to make one loop. While it is folded, make one cut. So this is one string, there's a little knot here, and I've made a cut, okay? And it says, how many pieces of string do you have? So if I make a cut and I cut through my string, I'm going to have this original piece of string, okay, which is one. Then I'll end up having two, this piece here that's been cut off, and three, this piece here that has been cut off, okay? Because then it will tell us fold another piece of string to make one loop, make two cuts, and then you repeat this 3, 4, and 5 cuts. So you would keep doing this process where you would keep picking up this original string and making cuts, and you would be adding to the pile of what was already there, okay? So for B, it's going to say organize your information in a table. What do the variables in your table represent? So I'm going to show you that. So for B, here is B, okay? Here's our table. X is going to represent, and you're going to be copying this down, please, under B. X is going to represent my cuts that I made in the string. Y is going to represent the pieces that are left over once I make the cut, okay? So in that first original picture, remember there was one string and I made one cut. And when I made a cut through that string, I had 3 pieces that were left, okay? So then if I take it and I make 2 cuts, what's left? I've got now 5 pieces left. If I were to take that string and make 3 cuts to that original string, I now have 7 pieces left. If I were to make 4 cuts to that original string, I now have 9 pieces. And then lastly, if I had 5 cuts to that string, I would now have 11 pieces. Okay, so there's definitely something that's taking place here. There's a rule taking place. You're doing something with X in order to get Y. Okay, so you want to kind of think about that. I'm going from a 1 to a 3, a 2 to a 5, 3 to a 7, 4 to a 9, 5 to an 11. Okay, so there's a rule taking place between your X and between your Y. If you look at question C, it's going to say and actually ask you for C, what relationships do you actually see? So looking at your table. And then it'll even say predict the number of pieces of string you would have after 8 cuts, because once you can figure out what the rule is, then you can apply it with even the 8, okay? So looking at your table, I'm hoping that some of you may have recognized this rule here. X times 2 plus 1 is going to give me my pieces. Okay, and some of you might be thinking, well, where am I getting that plus 1 from? Does anybody know? Think about it. Where am I constantly adding the plus 1 to every time? If you were thinking, well, she's getting the plus 1 from the original string, you would be correct. So I have that original string. Here it is, this original piece of string. You're always including this original piece of string when you make your cut. That's a part of the count. Okay, that's where that plus 1 is coming in. So if I wanted to do 8 cuts, then I can figure out that 8 times 2 plus the original string cut, I would have 17 pieces of string. Okay, and again, this is for C. All right. D says, complete the following statement. As the number of cuts increases by 1, the number of pieces of string, we should say, it's going to tackle 2 because we're timesing it by 2. It's like you're doubling it. Okay, you're timesing it by 2, and then you're adding that 1. So D would be 2. Okay. Then it says, in your table, this is E, in your table, for each number of cuts, write an equation that shows a relationship between the cut number and the number of pieces of that string. So again, all we're doing for E is we're just repeating the rule. You know, what is the rule? And again, for E, that rule is X, that's the number of cuts, times 2, plus 1 equals, because we're doing an equation, so I'm putting an equal sign, equals Y, which represents my pieces. So that's my equation I'm using every time, and it matches this up here. X times 2 plus 1 gives me Y. Okay? If you look at F, it's going to ask find a relationship between the number of cuts and the number of pieces of string. How would you represent in your words? So all you're doing is taking the equation, the rule that we just did, X times 2 plus 1 equals Y, and you're telling it to me in words. And then it says describe it again using variables. So again, all you're doing is you are doubling the number of cuts and adding the original piece of string. And that's where you're getting this equation, okay? So again, you're doubling the number of cuts and adding the original piece of string. That's what you're doing. The key is to make sure not to forget the original piece of string that you started off with when you made your cut. Okay, so that's F. That's how you would view it, and you would write it in words. Okay. All right, G is going to ask you, did you see the same or different variables to represent your two quantities and why? Remember, our equation was X times 2 plus 1 equals Y. We used a variable of X, we used a variable of Y. So the question says, did you use the same or different? Well, obviously we used different. Think about why that might be that I had to use different variables. Okay, we've talked about that before, and I'm hoping for G that you were thinking that different variables are represented by different values. Okay, so different variables because they represent different values. Okay, and we've talked about that a lot. So different variables because they represent different values. For H, it says, why do you think your rule represents the relationship? Can you explain your rule in terms of the problem context? Well, we tested this rule. We tested it when we made cuts 1 through 5 on our table. And when we applied this rule to this table, okay, and we did X times 2 plus 1, it worked for everything that we applied. So for G, simply, we're just going to say they all had the same rule when tested. Okay, so it applied because it had the same rule when I tested it. And lastly, it's going to ask us for I. It's going to ask us, you know, what's going to actually happen if I were to make 80. 80, cut it 80 times. That's a lot. So I'm just going to apply that rule. I'm going to plug in 80 cuts, I'm going to double it, and then I'm going to add that original string back. And if I say 80 times 2, I know that's 160 plus 1 gives me 161. Okay, so again, we were using a pattern, input-output, based off of cuts and pieces left over. Okay, if at any point in this part of the video you need to pause it, so that you can catch up, or you even might have to go back and rewind it to be able to fill in what I talked about and write, then that's what you're going to need to do. Okay, but I'm going to move on now to lesson 16. All right, so have your lesson 16 out. Lesson 16 is going